Hey there! In the next few videos I will take you through a new amp project that I've started. This is a Mark IIB XHR that I will be refreshing and updating with a GEQ, making a new front panel and converting it to a head with a new hardwood head shell. Originally it came as a combo with a 15-inch electro voice speaker. The amp was listed and arrived as serviced, but it was unstable and it had some major issues with noise, crackles and oscillations. There were some weird, badly done mods. Some traces were cut on the preamp PCB and some components were changed. I sorted out everything on the preamp board and the amp worked fine after that. But I did all of that before deciding on keeping it and before planning this project, so sadly there is no actual footage of the process. But there are still some important things that need to be fixed before I can move on to the upgrades. First, let's drain the filter caps and render the amp 100% safe. I just played the amp and checked it on the oscilloscope, so there is definitely high voltage left in those filter caps. As we can see, the power supply has been recapped, but with the incorrect values for this model. High quality brand caps, but just not the right ones for this amp. The previous recap was a bit sloppy, so I will be sorting all that as I go. 2 of the 4 caps for the high voltage nodes were changed to 47 microfarad, so I am putting the correct 30 microfarad caps. I will come back to those 1K decoupling resistors later. Some PCB cleaning is a good practice, as old leftover flux and gunk can become conductive with time, and especially in high voltage scenarios, quite dangerous. The 2 main filter caps were changed to FNT 100 microfarad, and since they are in series, that equals to overall 50 microfarad filtering. The original amp used 220 microfarad caps, and that equals a total of 110 microfarad filtration. This is quite a big difference from the original, and with more filtration there will be less sag in the power stage and the amp will sound tighter and bolder. In the simulclass Mark II and Mark III amps, there are 2 additional 220 microfarad capacitors in parallel to the already existing ones, which doubles the overall filtration to 220 microfarad, so further tightening those amps. The original foam cushioning was ripped, so I am replacing it with a new piece. Those foam pieces reduce vibrations going through bigger and heavier components and reduces the chances of weakening or cracking their connection to the PCB. In this case it also helps lift the 2 caps so they are not resting on top of the 2 drain resistors. Here I checked the 2 resistors and they were out of spec, sadly not visible on the video. So I replaced them with higher quality, 3-watt metal oxide ones. While here, I decided to replace the second foam cushion to a new one, so when the new components go in, they will be pressing evenly and sit leveled. Firmly pressing down both resistors into the foam, so they'll sit just below the new capacitors. Before soldering the new caps in place, I am putting some insulation, since they are shorter than the original sprigs and the exposed leads can be dangerous. Pressing them down into the foam pads so they still sit leveled, but are also not resting on the resistors below them. Making sure everything is neat and sitting tight. Time to solder everything. The next issue is the bias capacitors. They should be 47 microfarad and preferably 100 volt rated. Whoever worked on this amp before me put different value ones, a 147 Sprague and one 100 FNT, but at least they were both rated for 100 volts. I spotted a wire with some melted insulation, probably with a soldering iron, and the wires were exposed, so I will be fixing that later. Now back to those bias caps. Here they are. Definitely replacing those. For now I am putting Illinois 47 microfarad at 100 volts until some better FNT caps arrive. Now let's add insulation to that melted ground wire. It's in such a spot that it's not in danger of shorting something, but I just want to make sure. Here I am putting back the main ground wire that goes to the chassis star ground. Prepping and populating the power supply for the new GEQ. Just a 1N4007 diode and a 220 ohm current limiting resistor. From there, a new wire will be added to feed the GEQ driver board. While I was working on that, I noticed that the connections for the high voltage and the 50 volt tap coming in from the power transformer needed some love and attention. Simple retouch and reflow. Just making sure everything that's been worked on before me is bulletproof for another 40 plus years. Finally, checking if the 1K decoupling resistors have drifted and if they need replacing as well. I may change them later to 5.6K, as seen on some amps, as a simple way to tweak the amp's response. But for now they read fine, and I will leave them in, even though I despise carbon composition resistors in power supplies. The 60 to 100 watt switch had been messed with for some reason. The wire that goes to the switch had a very cold looking solder blob, and I also want to connect the other side of the wire more securely to the PCB ground plane, instead of it being attached to one of the capacitor legs, using a new wire that's a bit longer, just so it has enough slack to maneuver around the GEQ later. Tidying everything with some cable ties and screwing the PCB down. The board will be lifted again later when I run the power wires for the GEQ. Aligning the switches so they are all level before tightening them back up. Then some hot glue to further secure the main capacitors. So that's it for the power supply. Here are some close-ups now. Stick around for the next episode of this build where I will be making and prepping the new GEQ boards. See you next time.